Okay, now we can rock and roll with the sentence transformers. Go into the main.py. I'm going to import NumPy first, which was installed. And again, we're going to load a model. It's a super small model that is going to work on this limited resource machine that's old. Of course, if you have a fancy graphics card or even a mid-range one, you can just do it on your graphics card. This is for the people like me with old systems. Specifically, having an old systems to make it easier to teach to a wider available audience. Okay, so this is basically the smallest model that you can use. It's going to download it and it's going to cache it. So just to let you know what's going on before you run the program, when you first run it, it's going to save it to your cache in your local directory. So I've already downloaded it prior to this tutorial. So I have the model that's already, it's going to be cached right there. The first time you run it, it's going to download it from the internet. You have to be connected to the internet and it's going to cache it. After that, you don't need to be connected to the internet. And just make it simple for this test. So we're going to set up our messages or sentences in a SQL database eventually, and I'll read it from there. But for now, we'll just have it in a list here of strings. We have a kind of apocalyptic game here. I'm going to separate the sentences. These can be any sentences, by the way. The girl's name is Aki. And the guy's name is actually Hiroshi in our story. And he's having some hard times because he's been beaten down. But she's going to cheer him up eventually with a mission. Now we need to set the vectors. A vector is a set of numbers. All right, so we already have our models here. The model is set up from the sentence transformer, which we just imported, which uses PyTorch. So we can just encode the sentences right here. We'll use NumPy to convert it to an array of float 32 as type float 32. Okay, let's print it out. And we'll run it. And it takes a while, depending how fast or slow your computer is. And eventually you get this structure here. It's a two-dimensional tensor. And there's these weird words. Tensor or matrix. Actually, it's a 2D array because it's coming from NumPy. It's the NumPy array here. But we're using it with PyTorch. So we'll use it as a 2D tensor. It doesn't matter what this is, this structure. We're just going to drop it into the Facebook AI similarity search. And I'll just cover it now because it's kind of difficult to understand why you want these numbers. So I did add Facebook AI similarity search. Okay, so it's a similarity search or vector database. Oh, maybe I should put it in here. All right, it's actually relatively simple to use. We have to pick some type of index. So flat L2 384 384 dimension for the embeddings. Okay, lots of fine words, but you can see the code itself is pretty short, right? Vocabulary is kind of difficult to understand. Like you're like, what the heck is this flat L2? So this part, the flat exhaustive search, Euclidean distance or L2, it doesn't matter. I think we can just use it, and we're not building these type of algorithms ourselves. So our purpose is simply just to use it. Okay, we're going to now add the vectors to our index here. And now we can run the search. So our data is, let's say, a glowing ramen shop in the, or how about Aki orders a bowl of ramen, but we don't remember like what she ordered. We don't remember her name, let's say, right? So let's try the query equals woman eats noodles. And if it was a keyword search, you wouldn't find it. There's no word noodle here. It doesn't mention the word woman. But let's find out. I haven't actually tried this. First, need to encode the query back into these numbers. So same as here, we have to encode the query itself. We've encoded the data that we are searching through, but we also have to now include the query. And find the two most similar sentences. We can tell it how similar, what do we want, EI, these are just variables, index, it's from our database, and keyword search from the database, u back a equals 2, and this is the 2 right there. So our core data, which is in just a standard list of strings at the index. I think I'll give it a little bit more clue here. Doesn't know that Aki is a woman, and we will run it. And the first match is Aki orders a bowl of ramen. Just see whether we can confuse it a bit. Aki gets into a fight and runs away. So it still finds the ramen. Ramen is a type of Japanese noodle. And at least it's smart enough to understand that ramen is noodles. I'll try another test here. There was a battle. And it does find the correct one where it's finding battle or fight. And I guess the rest of it is probably the main clue for it. All right, congratulations. I'm going to cover the concepts in the next video. Some people like to learn by code. Some people like to learn through slides. And maybe most people they want to learn a bit from both. Okay, what did you learn? Well, you can now use a vector database. That is the Facebook AI similarity search. It's a library, C++ library with Python bindings, and we did use it. So you can understand how it works. We use the PyTorch, which was part of the sentence transformers, if you recall. Remember, we imported it up here, and in the beginning it did install PyTorch with the CPU. And you now know how to convert the text into numbers. The numbers are, when they're in a list like that, they're called vectors. They're also called embeddings in our use of it. You can do a similarity search, which is not a keyword search, which you learned in the SQL portions. And we will also cover SQL, but for the searching of it, the fuzzy searching, we're using a vector database. And you most likely know that the vector databases and the embeddings, all of this is also used with the LLM or the large language model. probably most synonymous with AI, right? So an AI person. But you don't have to use these techniques. Probably you will use the vector database, but it often sounds more difficult than it really is. And then there's a whole bunch of new words, or maybe it's new. It's new for a lot of people, the terminology, which sounds kind of intimidating, like Euclidean, L2 flat. Like, what does all this mean, right? I think you just start using it, and you'll be able to like input and output from the vector database, input output from the LLM, store from the LLM into the database, and eventually it will just start to get to know it. Unless you're a researcher and you're actually building the algorithms, which most of us aren't.